Hello everyone. So this is another example in which I am going to solve or analyze the beam using virtual displacement method. If you can look at here, this is also an example of determinate beam. As already discussed or said in previous videos, a displacement method is used to analyze determinate structure. So if you look at, so we know we have three equations of equilibrium, which is summation of fx is equal to 0, summation of fy is equal to 0, and summation of moment is equal to 0. And here if you look at, we have total unknown reactions here. Roller support 1, roller support, so 1 reaction, RA, RB, and here we have 2 reaction because it is hinge support. So we have total unknowns 4, but you can see we have 3 equations of equilibrium. But if you note here, we have another joint, hinge joint, for which when it is a hinge joint, that means moment at D is equal to 0. So this is our 4th equation. So total we have 4 equations, 4 unknowns. That's why this is an example of determinate structure. So if you look at what is hinge joint, that means this is 2 members which are joined by a hinge joint. So normally they show hinge joint as dot like this. It's not a support but a joint. Okay. So now solving this using virtual displacement method. So let us first calculate reaction RA. Okay, in order to find reaction RA, we have to apply a unit displacement at point A because it's a virtual displacement method. So when I'm applying a unit displacement at A, so this, as I'm moving here, this point to here, 1 unit displacement, so this beam will be like this. So this will bend here from joint D. Okay, this will bend like this. So, and the other part of the beam will remain straight. So if I'm going to calculate, so we have a load here 20 kilonewton. So total work done RA into unit displacement A, so force into displacement, minus, if I multiply 20, which is downward direction, 20, but there is no displacement, 0. So this is equal to 0 total work done. So RA is equal to 0. So there is no reaction, or you can say RA is equal to 0. Coming for B, to find out reaction at B, I have to apply a unit displacement at B. So let this be like this. So this is A, just to signify, I've just done point. So this is C. A, B, E, C. So here I'm going to find a reaction B. So I will apply a unit displacement at B. Okay, this is unit displacement at B. So when I'm applying a unit displacement, so this point moves to here, and that's why this part of the beam moves right like this. And because this is a hinge joint, so this will move up like this, and then again at support it will be 0. So our reaction RB into work done is 1 is minus, so the load is 20 here, so 20 into what is the displacement at this point. So displacement here at this point, let me take delta E. So delta E by this triangle, so similarity of triangles, the smaller triangle, height divided by larger triangle, this base is 2 meter divided by this base is total 4 meter. So deflection at E is half. So into half is equal to 0. This implies RB is equal to 20 by 2, 10 kilonewton. Then let's calculate the last reaction, RC. So in order to find RC, we have to apply a unit displacement at C. So I'll just put all the points, joints and the supports. So here I'm going to apply a unit displacement at C. When I'm applying a unit displacement, so this joint C, when I'm moving it, because this E point is just the where the load is applied, so this will move like this to support, and you can see this joint is there, that's why here it moves, and again to support it will be 0, the displacement. So here your load is, so what will be delta E by 1, because the triangle is this triangle with this, similar to triangles I'm checking. So delta E is this under the load E. Delta E by 1 is equal to, here the base is 2 meter divided by the total base is 4 meter. So again delta E is half. So RC into unit displacement 1, you can see there is no load in the other span. If there would have been any load, then again you should multiply the force into the corresponding displacement. Okay, but since we don't have, that's why we are not going to calculate or add anything. Otherwise you have to multiply the corresponding displacement under the load. So RC into half minus W, which is 20, into displacement is half, is equal to 0. So RC is also equal to 10 kilonewton. So this is how, once you know the reactions, you can draw the shear force and bending moment diagram. So hope this video is useful for you. Thank you for watching.